This is lesson 1 of chapter 6, and the title of this lesson is Solve One-Step Addition and Subtraction Equations. Essential question: what does it mean to say two quantities are equal? And in this lesson, we'll be talking about certain terms: equation, what an equation is, solution, equivalent equation. Okay, and we're going to add two more properties here. Uh, property, subtraction property of equality, and the addition property of equality. Okay, so all of these terms we will be discussing in this lesson. Objective of this lesson will be to solve addition and subtraction equations at the very top right there. And if you look at this one right here, it says scan the lesson, right, and the definitions of equations and equivalent equations. An equation is a sentence stating that two quantities are equal. So when you talk about an equation, usually, not usually, every single time you will see an equal sign. Equivalent equations are equations that have the same solution. So when you talk about that, if they have the same solution, then those are what we call equivalent equations. Okay, and this is the definition right here of what an equation is. Sentence stating that two quantities are equal. Okay, and to continue that, the sentence after that, the value of the variable that makes the equation true is called the solution of the equation. So when you talk about equations having the same solution, those are called equivalent equations. Okay, so knowing all that, let's continue with our lesson. And in our lesson, okay, let's take, for example, x plus 2 equals 6. Okay, so if we have x plus 2 equals 6, we want to solve x plus 2 equals 6, something like here. Okay, so to model that, this is how it looks like. Okay, this is x plus 2 equals 6. And if you notice, there's an x on the 2, which means you subtracted 2 to both sides of the equation. And when you subtract 2 to both sides of the equation, you end up with x because this one goes away. The 2 goes away. 6 minus 2 equals 4. So x equals 4. The value of x is 4. And therefore, if you go back to the definition of equivalent equations, x plus 2 equals 6 is equivalent to x equals 4 because they have the same value. Okay? X will have the same value for x plus 2 equals 6 and x equals 4. And that's basically what it's saying here at the bottom, where it's saying the equations x plus 2 equals 6 and x equals 4 are equivalent equations because, again, they have the same solution, which is 4. Okay? So let's do a little bit of an exercise here. Circle the equations below that are equivalent to x equals 3. Okay? So if we want to circle the equations that are equivalent to x equals 3, all of them should have the same uh, solution, which is x equals 3. The value of x should be equal to 3. We can use algebra tiles if we need to, but in this case, all we need to do is substitute the value for x. If the sentence is true, if x is equal to 3, and makes the sentence true, then it is equivalent to x equals 3. So if we substitute 3 to x, this becomes 3 plus 3 equals 6. Again, okay, that sentence is true. So we circle this. That's an equivalent equation. Okay. If you take a look at this one, if I substitute 3 plus 1 is not equal to 6, so therefore this is not an equivalent equation. Okay. Going down here, 3 plus 3 is not equals to 3. is not equal to 3, so therefore it's not, this one is not an equivalent equation. If you look at this one, okay, x plus 1 equals 4. We can make this 3, okay. 3 plus 1 equals 4, so this makes it an equivalent equation because 4 equals 4. In this case, 6 equals 6. So we circle that. And the last equation that will be true will be this one, because if I substitute 3 to x, it becomes 3 plus 2 equals 5. And we know that 5 will always be equal to 5, so we circle that. Okay? So those are the three equivalent equations to x equals 3. Okay? All right, let's take a look at the bottom real world example. Okay, real world link. Robin had some video games and then she bought 4 more games. Now she has 10 games. This scenario can be described using the equation x plus 4 equals 10. Again, Robin had some video games, we don't know how much. Then she bought 4 more games. 4 more means plus 4. And now she has 10 games, so that means she has a total of 10 games right here. And we can describe the scenario as x plus 10, x plus 4 equals 10. So again, what does x represent in this equation? We are going to define x, okay? In this case, let x, okay, represent the number of games Robin started with, okay? So that's defining x, okay? We defined x as the number of games Robin started with, okay? Number 2, write 2 different equations that are equivalent to x plus 4 equals 10, okay? So we can write another equation here. To make this equivalent, we can probably say x equals 6, okay? Because if we get 6, substitute it to x, it'll be equal to 10. So that's one equivalent equation. Another equivalent equation can also be 2x equals 12. Because again, if we substitute 6 with x here, 2 times 6 is 12. So they are equal to each other. And these 3 equations are all equivalent equations because they have the same solution, and the solution is x equals 6. Okay? All right, let's talk about one property of equality. There are 4 properties of equality that we'll be discussing in the next 2 lessons. Okay, so in this case, we'll be describing the subtraction property of equality. What does the subtraction property of equality state? In words, this is what it's saying, that the subtraction property of equality states that 2 sides of the equation remain equal when you subtract the same number from each side. Okay, so in symbols, this is what it's saying, is that if you have A is equal to B, then if I subtract C to A, subtract C from B, okay, A will still be equal to B, okay? So basically what it's saying in this, with the subtraction property of equality, since we are dealing with an equation where both sides are supposed to be equal, whatever you do on the left side of the equation, you need to do on the right side of the equation. So in this case, if I subtract C from the left side, I need to subtract C from the right side. That is what we call the subtraction property of equality, and it will not change, okay, how those 2 expressions on both sides are still equal. You can use bar diagrams and work backward problem solving strategy to solve equations arithmetically, or you can use the properties of equality to solve equations algebraically. So we won't use the bar diagrams at this point. We will use, okay, the subtraction property of equality. Again, as a summary, whatever you subtract to one side, you need to subtract to the other side of the equation. Remember, the side is uh, marked by the equal sign. So this is the left side of the equation. This is the right side of the equation, separated by the equal sign. Okay, so first let's write the equation down. The equation is x plus 6 equals 4. Okay, again, the objective of our equation is to isolate x. Okay, for us to isolate x, we need to undo, okay, we need to undo uh, the 6. Okay, for us to undo 6, for us to undo addition right here, okay, we need to use subtraction. So for us to undo addition, we use subtraction, the inverse operation of addition, and we are dealing with an equation. Whatever we do on the left side, we need to do on the right side. So using the subtraction property of equality, we actually subtract 6 to both sides. So by subtracting 6, okay, the 6 goes away, that is a 0, and we're only left with x. And we know that 4 minus 6 is negative 2, so we have the value x equals negative 2. Okay, so let's see if that's right by checking our answer. If we check our answer uh, for this, x plus 6 equals 4. We get the value of x, which is negative 2, and substitute that to x. So now we have negative 2, okay, plus 6, is it equal to 4? That's why there's a question mark. And we know that negative 2 plus 6 is 4, so they're equal to each other, okay? And the solution, therefore, is negative 2. So the solution in this case is x equals negative 2. In number 2, negative 5 equals b plus 8. Okay, in example number 2. Again, we copy this the equation down. And we have now negative 5 equals b plus 8. Look at our equation. Our variable is on the right side. Therefore, we need to undo positive 8. So again, the inverse operation is subtraction of addition. Okay, so we're using the subtraction property of equality. For us to undo positive 8, we need to subtract 8. But since it's an equation, we subtract to both sides of the equation. We now have b. Okay, this becomes 0. We're left with b. Negative 5 plus negative 8 will give us negative 13. So b equals negative 13. Okay, so checking our answer if it's correct or not. Let's see if our solution is correct or not. Sorry about that. Get that out of the way there. Okay, we get negative 5, the original equation, which is negative 5 equals b plus 8. Substitute the value, which is negative 13. This now becomes negative 5 equals negative 13 plus 8. Are they equal? Okay. Thus the question mark. We know that negative 13 plus 8 is negative 5, and they're equal to each other. So the solution in this problem is negative 13. B equals negative 13. So do the got it problems and let's see if you understand examples 1 and 2. Okay. Example number 3. An anglefish can grow to be 12 inches long. Okay. If an anglefish is 8.5 inches longer than a clownfish, how long is the clownfish? So let's take a look at the words. Okay, we know that an anglerfish is 8.5 inches longer than a clownfish. Okay, we don't know the length of our clownfish, so we let C represent the length of our clownfish. So in this case, we don't know the value of or the length of our clownfish, and that's how we will represent our variable. Let's see, represent the length of our clownfish. And as an equation, let's take a look at this. An anglerfish can grow to 12 inches long. So therefore, we can do 12 equals the length of our clownfish, which is C plus 8.5, because we know that an anglefish is 8.5 inches longer than a clownfish. So that makes it C plus 8.5 will be the value of our anglefish. So for us to be able to solve this, we need to solve for C. Therefore, we need to isolate C. We need to undo 8.5. Okay, in order to do that, first copy down the equation. Okay, and then we use the subtraction property of equality by subtracting 8.5 to both sides of our equation. Okay, so this one goes away. That's a 0. We simply bring down C here, and we know that 12 minus 8.5 will give us 3.5. So the value of C is 3.5. The clownfish is 3.5 inches long. Okay, do the got it problem D, and let's see if you understand example number 3. Now let's talk about another property of equality, and this is a little bit the opposite of your subtraction property of equality, because in this property of equality it's called the addition property of equality. And it simply states that the addition property of equality states that the two sides of the equation remain equal when you add the same number to each side. Remember, in the subtraction property of equality, whatever you add to one side, whatever you subtract to one side, you need to subtract to both sides, to the other side of the equation. Okay, in the same manner, whatever you add to one side of our equation, you need to add to the other side of the equation, and that's how the addition property works. Basically, when you talk about properties of equality, there are 4 of them. It's basically saying that whatever you do to one side of the equation, you do exactly to the other side. So here we're adding C to one side, therefore we're adding C to the other side. In the subtraction property of equality, we subtracted C to both sides of the equation. Let's take a look at example number 4 and see how this works. You have x minus 2 equals 1. Okay, first let's copy the problem down. X minus 2 equals 1. You notice it's x minus 2 now. Remember, we talked about this in the past. When we say x minus 2, it is the same as x plus negative 2. So therefore, we need to undo negative 2. Remember this, the definition of subtraction is what you're seeing here. Okay, so for us to do subtraction, okay, we need to do the inverse operation, which is addition. That's why we're using the addition property of equality. So for us to undo negative 2, we add 2 to both sides. Okay, so add 2 here, add 2 here. Okay, again, whatever you do to one side, you do to the other side. This goes away, simply bring down x. We know that 1 plus 2 equals 3, so x is equal 3. Okay, so the solution is equal to 3. And if we check it and substitute the value of x, okay, so if we do 3 here, 3 minus 2 equals 1, there you go. We know that 3 minus 2 will always be equal to 1. We've checked our solution. Okay, do the got it problem E, F, and G, and let's see if you understand example number 4. And finally, in example number 5, okay, we always go back to a word problem. In example number 5, it's saying that a pair of shoes costs $25. Okay, this is $14 less than the cost of a pair of jeans. Find the cost of the jeans. Okay, now we don't know what the cost of the jeans is, so this is what we are going to represent as our variable. Now take a look at these words. When you say $14 less, this means minus 14. Okay? Just like when I say what how uh, if uh, if your brother is 3 years less than your age, okay, what is the age of your brother? So you're subtracting 3 there in my sentence. In this case, it's the same case. This $14 less, it's minus 14, okay, and it is not 14 minus. So remember, minus 14 is not the same as 14 minus, okay? That's due to the fact that subtraction is not commutative. So knowing that, we know that we will represent our the cost of our genes as our variable. Okay, so let me finish this up. Shoes are $14 less than your jeans, so we'll let J represent the cost of our jeans. Okay, write down the equation, which means 25. Okay, pair of cost of our shoes. Okay, is $14 less than cost of our jeans, J minus 14. Also, one more tip, the word is can always be translated to an equal sign. So basically here, $25 is $14 less than the cost of our jeans. We need to undo negative 14. For us to undo negative 14, we add 14 to both sides. This goes away, J goes down here, 25 plus 14 is 39. So J is equal to 39, which simply means that the cost of the jeans is $39. Okay, do the got it problem, and let's see if you understand example number 5. And that's the end of our lesson. Thank you for watching.